Nuclear fission. The process of splitting of a heavy nucleus into two lighter nuclei of comparable masses with liberation of energy is called nuclear fission. The process of splitting of a heavy nucleus into two lighter nuclei of comparable masses. This is after bombardment with a energetic particle with liberation of energy is called nuclear fission. The phenomenon of nuclear fission was first discovered by scientists Otto Hahn and Strassmann. The phenomenon of nuclear fission was discovered by scientists Otto Hahn and F. Strassmann and was explained by Niels Bohr and J. A. Wheeler on the basis of liquid drop model of nucleus. Here we assume, suppose this is like uranium-235. Now a neutron comes and hits it. So this neutron is captured by the nucleus of this uranium. In turn, thermal vibrations are set up. So the nucleus starts vibrating in this zone, in this direction, and after some time it becomes dumbbell shaped and slowly it will be splitting into two parts. One of the part will move in one direction, another part will move in another direction, releasing three neutrons. So this is called liquid drop model. So as this excess neutron is captured by this uranium, thermal vibrations are set up, it becomes unstable, it starts vibrating violently and slowly the nucleus will start vibrating and takes a shape of liquid drop. This will be extending maximum and suddenly it splits up into two nuclei. Let us see this animation to get the correct explanation how the neutron is splitting or uranium nucleus is splitting into two parts. In the fission reaction of uranium-235, 92 uranium-235 plus one neutron is captured. It becomes unstable, 92 uranium-236. Now it is unstable, splits up into equal fragments nearly 56 barium-141 plus 36 krypton-92 plus 3 neutrons 0 and 1 plus huge amount of energy is released. Nearly 200 MeVs of energy is released. Let us see. Now a neutron is coming from here and hits. This thermal vibrations are set up and splits up into two parts, releasing three neutrons. Let us see this animation again. Splits up, releasing huge amount of energy and three neutrons. 92 uranium-235 when captured by a neutron. It becomes unstable 92 uranium-236. In turn, barium-56 and 36 krypton plus 3 neutrons are released plus a huge amount of energy released. The energy released in uranium-235 fission is about 200 MeV, million electron volt, or 0.8 MeV per nucleon. By fission of 92 uranium-235, nearly 3 neutrons are liberated. These neutrons are called fast neutrons and their energy is about 2 MeVs each. These fast neutrons can escape from the reaction, so they need to be slowed down if the reaction has to continue, and that slow neutron has to be captured by another neutron. Fission of uranium-235 occurs by slow neutrons only of energy about 1 electron volt, or even by thermal neutrons of energy about 0.025 electron volts. A 50 kg of uranium-235 in fission will release nearly 4 into 10 power 15 joules of energy. The nuclear bomb dropped at Hiroshima had this much of explosion power. The mass of compound nucleus must be greater than the sum of the masses of fission product. Now remember this point, that it's not necessarily that in each fission of uranium the two fragments are barium and krypton are formed, but they may be any stable isotope of middleweight atoms. Some other uranium-235 fission reaction are 92 uranium-235 plus 0 and 1 gives 54Xe 140 plus 38Sr 94 plus 2 neutrons plus energy. Or it can also be 57Le 148 plus 35 barium 85 plus 30N1 and many more. The neutrons released during the fission process are called prompt neutrons. Most energy released appears in the form of kinetic energy of fission fragment. So when a slow neutron is captured by 92 uranium-235, it becomes unstable and splits up into two parts. One we call suppose barium, another you have taken suppose as krypton. Then in turn three neutrons are released. So maximum energy appears in the form of kinetic energy of fragments. Neutrons also carries energy and energy is released in the form of photons. For example, in this case, so this neutron slowly is coming and captured by the uranium nucleus, splits up into three. So this neutron is coming from here like this, and now this becomes unstable. Now it's ready to bombard. So it barium, krypton and three neutrons in turn releasing huge amount of energy.